Hello everyone, this is Amir from Audio Science Review. I have another product review for you in the form of a aftermarket AC power cord by a company called GR Research. This is the cable. Typical of these aftermarket cables, size matters. So the thicker they are, the typical person thinks they're better AC cables. So it's mandatory to make them this thick, even if the conductors inside are not. This one's called the B24, which I assume it has 24 wires, I think 12 per plus a ground. Not sure, but that's what it's called. They also have a B16 version of this, which is thinner, so I opted to get the more expensive one, get the full treatment. I paid $349 for this cable plus $40 in shipping to get it in a couple of days. I think regular shipping was $25. And so as high-end cables goes, it's not outrageous, although I've tested aftermarket cables that cost $40, $50, $60, $80, $100. So it's priced low relative to the garden hose size that you see. Sadly, it didn't come with these Velcros. I put them on. You would think that they would throw a couple of them in there to, if you're not using it, to be able to contain the size and shape of this thing. When I first tried to use this cable, I could not. When I tried to plug it in, this earth pin was so large and so wide that I could not get it into the outlet that I was plugging it into. It took incredible amount of force to push this thing in the first time. After about 5 or 6 times, it started to get some scratches and wore out, or got a little bit more compact, I don't know which, or damaged my outlet, one of both of those things. And it got a little bit better, but still, I'm talking about 50 times more force to plug this in than any kind of generic thin, standard IC cable that you get. But the bigger problem was that when I plugged it in, it wouldn't work. I was like, wow, how could they, so many strands going from one side to the other. Surely it's got to work. I had it plugged in. This side, I wiggled it every way I could, and it was plugged in properly, and it's still no power. So I went to pull it out of the outlet, and I noticed something, which is this, which is, I don't know if you can see it on the side better, but as you try to push this monster, cable in, this jacket actually slides up and down. So you're trying to push it in because this pin is so hard to get in there. As you push it forward, look at what happens. This thing comes forward so far that these pins are barely going past it. So you think you've got it plugged in and it's flush with the outlet, but in reality, these two pins are not making contact. So, and that's what was happening, is that it was in there, it was secure because this monster earth pin was holding it, but it wasn't. So to get it in there, you have to simultaneously pull this back while you push the cable in by the girth of the whole bundle, and you're fighting the pressure of this pin. And it was just a nightmare. Every time I had to switch and plug it, unplug it, I was dreading it. I was like, what's the best way to do this testing without having to plug this in again or not? It's also exacerbated by the fact that this ground pin is actually pretty long. The ones that, usually it is more proud than these two, business end of the plug. But this is actually longer than usual, which means that you really got to force this thing in quite far before these two make a connection. There's danger in there that these could barely make a connection and as a result generate heat and actually make a poor connection, because it could look like you've plugged it in, but in reality, you basically have inserted most of this pin in the earth pin, and the two, hot and neutral haven't gone in there. Looking at it right now, I see that it's scratched up from the hole up, but the rest of it is not scratched up that much. So it just, high-end cables may not have Audible benefit, but a lot of them are put together extremely well. I mean, some people call them, audio jewelry for that reason. Whether it's functionality or usability, this thing is just a total disaster. So at some level, I don't care what it does. If you can't plug it in and get it in there, what kind of usability testing did they do? Beta testing, anybody getting this cable? will surely complain saying, oh my God, this thing is just a nightmare to plug and unplug on this thing. There's no other marking on it. Strangely, it came with a masking tape with U or N written on it. I don't know what that is about, why this wasn't taken off. This end of it, the IC plug side has some kind of CE mark on it. So wherever they source this part of it, there's some kind of certification got into just the plug. This side, I can't find anything in here. And even if these were safety regulated, the whole assembly is unknown. So, you know, let's say you get a short in your equipment, you're relying on a very strong and low impedance path between these, you know, going through, coming out to the outlet. And who knows if this is compliant or not? You know, we want safety experts looking at something like this, and that you're going to plug into the wall, that you're going to leave unattended, and make sure that it is safe. You know, audio is a great hobby, but it's not worth, you know, setting your house on fire. Now, these things obviously don't happen. It's a 1 in a million chance, but if it happens to you, it doesn't matter that it's a 1 in a million chance. It's happened to you, and it's bad. So personally, you know, even if it had Audible benefits, it's just, there's so many reasons to not like this. I should say that half a dozen or a few other AC cables, aftermarket AC cables I've tested, they also don't have certification on them, which is very disappointing. Yes, it costs $2,000 or $3,000 or, you know, thereabouts to go get a UL tested for US. But hey, you're selling me a shortest cable is almost $400 for the price of 4 or 5 of them. You know, get me a safety certification so I can sleep easy on this thing, on that. So a lot of misses, but, you know, let's put that aside. You might be wondering why I'm wearing a t-shirt. This is tries to settle the argument that Earth is not flat, that NASA has seen it with their spaceship. And the reason I'm wearing it is that the company's owner, Danny from GR Research, wore this to say that people who say there's no audible difference between these cables and others must be thinking the Earth is flat. So I thought it was fitting that I wear the same t-shirt as he did, and we'll find out who thinks the Earth is flat or not. So with that introduction, you don't need to look at me anymore. Let's look at the cabling. I already explained this thing. You can see just sitting in here how proud this sleeve is. By the way, this sleeve is supposed to be some kind of shield. It's a little, some kind of copper sleeve or something, which is fine, you know. If they want to shield it, they want to shield it. But then the only thing that seems to hold it there is this heat shrink tube. And the heat shrink tube is attached to this jacket in here. And so, of course, the whole thing just moves back and forth. Maybe it was supposed to be glued and wasn't. I don't know. And then here I show you how much, you know, how proud this ground pin is relative to the 2 main connectors on this. So the company in the video says, look, go ahead and try this. You know, if you don't like it, return it. So before buying it, I went and looked at their terms for returning it. It says that, A, you have to pay for the shipping from both directions. So I'm out $40 coming to me. So, you know, if somebody doesn't have a commercial account, shipping account, going back probably will cost them another $40. And then he says you got to pay us the credit card transaction fees too. Excuse me. I'm like, whoa, what is that? You're going to charge me, you know, best case is probably 2.5%, but, you know, maybe they charge you 5% of this thing. So you add it all up, you're out $80, $90, you know, if you're not careful, to send the free cable back. So this is not a free evaluation by any stretch. I don't think you could just, you know, listen to it and you think it made no difference, send it back, you're not out anything. You're out, you know, almost $100, and you could buy 50 other AC cables for that same price. So it better do some good, and it better produce some results. I try to do always some basic, you know, tests on things, and here I just measured the DC resistance of the one end to the other. You need to have a special meter that can measure very small resistances, and I did. And I then converted that resistance to how much it is per meter, because the other cables that I compared it to, the Pangea and AudioQuest, and the thin cable I use for comparisons, they come in different lengths, and they're all actually longer than this. I didn't want to buy a longer one because it was $400 as it is with this shortest length. So, but if we normalize everything to milliohm or thousands of an ohm per meter, the GR research cable is only 4 milliohm per thousand per meter, or if you had 1,000 meter, it would only be 4 ohms. The Pangea cord that I have is an AC14SE. It's also a thick cable, but not as thick as this. So as a result, it's actually 9 milliohm per meter. I had an AudioQuest NRG X3, I believe, that I reviewed recently, and that one's 11, so a little bit worse than this. And for the bulk of the tests you see in here, I actually picked the exact opposite to show any difference that might be, which is a very thin Chinese-made cable, although had nice specifications on the outside jacket and so forth, which this one does not. And it naturally had more resistance, so 81 milliohm. But again, remember, this is 81 thousandths of an ohm for 1 meter. So if you do the math and you pull 15 amps out of this cable, so about 1,800 watts or so, you will have a 1.5% voltage drop with the thin cable that I use, this one, versus 0.1% for the GR research. So technically, there's less drop. Now, that's negligible drop in the bucket. Your equipment doesn't care. I think 1.8 volt voltage drop at 15 amps continuous, which none of your equipment going to do that. Even power amps will have cycles in them. But anyway, given benefit of doubt, yes, if you stack so many conductors, for each pin, you're getting essentially a very thick gauge cable. I'm not going to try to guess, but maybe it's like an 8 gauge or 6 gauge cable you're getting. Now, you would think that this would then get the company to recommend that you hook this up to your power amps. But ironically, I don't know if it was in a video promoting it or on the forum discussions, they recommend that you use this thicker cable for your source products, your CD player, your DACs and preamps, and use the thinner cable, the B16, for power amplifier. Don't ask me to explain why. I don't work here. The logic of subjectivist audio does not compute with me. So I follow instructions, and therefore I tested this device for, in my case, I used the preamplifier, which was the most convenient thing to test. I already explained there's no safety standards in here, and hopefully some of you will start insisting on only buying certified cables and nothing else on this thing. So now, typically, I would go and show you umpteen measurements at this point to prove that nothing changes in the output of the audio device. And people then don't read the rest of the review, where I often do listening tests, and complain that you just did measurements and the magic of these cables doesn't show up in measurement. So I'm going to not talk about measurements right now. I'm actually going to talk about how the cable sounds. So the target device that I use is this Topping A90 discrete preamplifier and headphone amplifier. It's an exceptionally high performance device and beautifully made with step ladder, volume control, and so forth. And it has an AC power supply inside of it. Therefore, it just accepts an IEC cable. So ideal setup for this. Some of these products have external power supplies that don't accept the regular AC cable. And then I did something else. Now, I could tell you that what I heard or didn't hear, but how do you know that's true? How do you know I wasn't biased for or against this cable? And so instead of that, I did another test, which is I used an RME audio interface. That's my desktop product. Audio interface I use to listen to everything. And, my headphones, normally I'm listening with the RME, but it has a, high performance analog to digital converter. And I captured the output of the Topping A90 when it's powered with a thin AC cable versus the GR Research B24. And then what I've done is that I capture the two analog files, converts to digital, and then I have them. But importantly, I perform a null test. Now, this null test is a smart null test in that when you do consecutive captures, there can be clock drift, where that means the two tracks aren't running in sync. There could be out of alignment. One may be a hair off than the other one. And so if you just do the dumb mathematical subtraction, the null actually is not zero, even if you have changed nothing. You will actually hear the music as if you had changed something. For me, that's the control, by the way. I change nothing in my setup, and I do two consecutive captures. If nulling them is silent, then I know that my nulling process is right. If I hear the music still, that means, the null is not correct. And in this case, it worked really well. And so I picked different kinds of music. One of them is this Vivaldi Four Seasons, one of my favorite composers. And I've got the details of the recording if you want to know in here. And I went ahead and captured it once with the thin cable. Let me see if I have my thin cable to show you. Yes. So this is the thin cable. As I said, it's a generic thin cable, nothing fancy. This is probably, I don't know, $7 or $8 cable. And I'm comparing it to this $400 cable. So not the fancier audio cables that I talked about before on this thing. So I played this Vivaldi track, captured it, and then I run it through both ways with two different power cables. And I run it through this great program called the Delta Wave that a forum member going by the alias P. Kane has written, which does a beautiful job of matching volumes and syncing two tracks down to subsamples. That means not just digital samples are aligned, but it actually is a fraction of a sample, which is what you have to do to get things to be lined up. When I do this, it computes the objective level of matching that it is finding. So it computes a difference and says, what's the difference ratio of that difference relative to the two originals? And it's finding that down here, you can see 93 correlated null is 93 dB. This is a CD rip, so best case is actually 93 dB. It's a dithered file, so instead of 96, we get 93. So essentially, our null is as good as the resolution of the original recording, and what is there lands as in the null itself. The spectrum is noise, and you can see the spectrum of the noise in here. It's purely around, doesn't look anything like music. There's none of the music spectra is in here. And I can save this file and listen to it. So let's go ahead and listen to this. Let me pause for a second and make sure this volume comes through. I'll be right back. Okay, I'm back. So I'm going to play the difference file between the two. And it's on a Dropbox. You can go download it and play with it. The link is here. So when I open that, you can see the Dropbox come up. And Dropbox is able to play these files in place. So you don't even need to have, download them and play them elsewhere. So fortunately, you can't see the bottom of my browser, but just trust me, I'm going to play this. Do you hear anything? I don't. Even my sensitive IEMs, and cranking the volume way up. If I go way, way up, where I would go deaf if music is playing, I just hear the hiss, and that's it. Usually Dropbox is also showing the spectrum over here, and you don't see that because there's just nothing to see. So I'm going to pause this and close this guy and go back. This music's copyrighted, so I'm not giving you the two source versions. But for the next two tracks, I can share the actual captures. I did not make the test blind, so you can actually download them, know which is which, and you're welcome to do your own comparison. It's from one of my favorite bands called Radical Face. I think the artist's name is Ben Cooper, and he has an album called Missing Film, and it's basically compositions that he created for different projects that didn't get used. And he was very kind enough to give away this album. I actually purchased it from Bandcamp, where you can donate any amount of money you want or nothing. There's also a site where you can get it for free, but I thought it was worthwhile to buy it. So if you like this music at all, please go and donate something on this. But you're welcome to download these tracks and use them as is. He provides them with no restrictions. So this one, I'm going to warn you, as soon as I play the first track, is going to be quite loud. So make sure your volume is down a bit, because it's a very dynamic track. And these, by the way, these two tracks, I didn't try to handpick them to disadvantage this test. It's actually part of my reference tracks that I use for testing headphones and speakers. So here we go. This is with a generic AC cable. So once again, Dropbox loads. Now you can see the peaks in here of the spectrum. So let me see if I can make this guy 0. No, you're still not going to see it. No, I lost my controls. There we go. So I'm going to play it again. It's going to be loud at the beginning. So I'm going to pause it here. So this was a generic code, generic chord. And now this is the GR Research version. All that's changed is the AC power chord. So let's go ahead and play this. Now, you're probably going to have one of three reactions. One is that you're going to say, well, I couldn't hear a difference. But some of you will think that the second version was better. Some might think that the first version is better. Indeed, when I listen to them on a computer, so I can quickly switch between them, sometimes I preferred one versus the other, and other times I couldn't tell the difference, depending on how I played them. If I played them inside Delta Wave where they're synced and one face to the other, I couldn't hear a difference. And by the way, which one's better changes depending on the sequence I played and what part of the music. So statistically speaking, in a cited test, it's all over the place, and it's okay for you to have had a preference. But if you want to know if you really heard a difference, then you got to pull them into an ABX program like Fubar and see if you can tell then if there's a difference, and you got to get it 8 out of 10 times or 9 out of 10 times to do that. But better yet, we could just subtract those two computationally, as I mentioned over here, and now I'll play the difference for you between the two, and we can all try to see if we hear anything. So now you can turn up the volume if you'd like to hear the difference. Nothing, right? Again, Dropbox is showing a progress monitor in here, and the progress monitor is showing nothing. There's no spectrum for it to show, and there's no difference. If I crank this way, 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 way up, I'm talking 50, 60 dB, raising the noise floor, then I can hear this impulsive thing that goes at a very regular cadence. What the cause of that is, I don't know. It's not music. It only happens once in a while. Certain would be anything that would get me excited, thinking that the two are different, and that's what this low peaking is over here. Once again, we're at 94 dB nulling, which is the noise floor of the source. So, and this is the spectrum you can see going all the way to above 20 kilohertz. It's just all noise. There's nothing else there. So mathematically, we know there's no difference between these two files. And so if you think in a cited test, oh, of course the one sounds better than the other, you just have proof that what you heard was not reality. You know, the reality is that when we subtract these two, when we align them, then the difference disappears. So whatever you think you're hearing is incorrect. So that was one track. Another track I have from this album that I use as a reference. Again, turn on the volume. This one is, even though it's from the same band, it's got a very different composition in it. And so let's play the generic track. So this generic AC cable. Let me stop it. So as I mentioned, these are reference tracks. They sound beautiful on my system. They sound gorgeous on good headphones. It has all the characteristics that people look for. Is there sound stage? Is there separation between instruments? Is there note decays you can listen to? All of that is there. As you can see, these transient, massive transients over here. It's got all of that. So this was with generic AC chord. And now let's play the GR Research version. I could listen to these tracks forever, but I won't bore you. So let's go to the difference. This time the difference is just as pure as you can get. So let's go ahead and play this, and you're welcome to turn up the volume now to see if you can hear anything in the silence. So got it up. I'm going to do the same thing, crank it up. I hear nothing but random hiss. Again, all of these tracks are available as a Dropbox download. I don't know if I'll keep them there forever, but if you're watching this video fresh and for a few weeks from now, you certainly can download them and listen to them. And, you know, you form your own opinion. You can get delta wave and null them yourself if you don't trust what I did. But again, this one also nulls down to the noise floor that we have 93 dB. So there's zero evidence that the GR Research B24 cable is able to modify the sound that you're hearing. We have objective proof using our ears. We have computationally subtracted two waveforms from each other, and we have nothing that would help widen the sound stage, tighten the bass, and you know, smooth out the highs, all this stuff people talk about, you know, blacker background, none of that is in there, or we would see it in difference tests like this. Okay? So we now have this. By the way, any track I throw at the system will do the same thing. I've tested more tracks than I'm showing you in here. I try to pick the shortest ones so that wouldn't take as much space on Dropbox. But there's nothing specific about these tracks. You know, if you think there's some other tracks that shows a difference, you have this cable you think makes a difference, give me, you know, comment and give me the track, and I'll create an alt test for it, and we'll go ahead and look at it. Now, if in their video, the company says the reason this cable sounds better is because it filters out I guess, interference coming into it. An AC cable, first thing happens is goes inside your device and there's a transformer there, which is a filter already. Then it gets converted to DC and umpteen amount of filtering is done to it. So why would an AC cable noise make a difference? There's no engineering reason behind it. But let's humor the company. And what I then did was that instead of using this cable as an AC cable, I treated it as an audio interconnect cable, meaning I hooked it up to my analyzer, output of the analyzer, input of the analyzer. It generated 121 dB SINAT, which means that it's always as perfect as by the way, so was a generic cable. Both of them work great as an interconnect cable also. Not that you'd want to use an AC cable for that purpose, but they did. But I wasn't happy with that. I wanted to see if I could induce a difference between the cables. So what I did was I took this cable and my cheap cable, excuse me, and I stuck a big transformer to it. I can't get to the transformer, but I've got a chunky big AC transformer that is part of my GRASS measurement system for headphones. And I brought it next to the cable and I rotated to get the sort of worst case inducement into it from the magnetic field of that transformer while it's plugged in. And with GR research, you can see it in blue over here. So relative to our tone, which is a 0 dB, this is minus 135 dB. So 20 dB better than threshold of hearing and at all frequencies. And then I put in my generic AC cord and it actually is about 20 dB worse. So, is that important? If you were using this cable as an interconnect, turns out even if you use these AC cables as interconnect, it wouldn't make a difference. I have scaled the threshold of hearing from Fletcher-Munson to match this graph. It's sort of non-trivial. You have to understand how you're doing it, and there's specific reference to 120 dB decibel. But essentially, if your playback peak level is 125 dB, this would be per frequency noise level. So therefore, all of these spikes fall well below it, and naturally so, where our hearing is not sensitive to low frequencies. So we see that even my cheap cable, used as an interconnect, it still would be inaudible and would be totally silent on this thing. So yes, the weave that they have does provide some cancellation, or you could say maybe generation, but it certainly is doing what it says it's doing. It's just that it's not important. It's like somebody says, if you wax your tires, you'll be smoother. It's like, yeah, it'll be smoother, but when I drive it on a dirt road, why would I care? That is a little bit smoother. Anyway, car analogies are terrible. I shouldn't have gone there on this thing. So, I just want to say what's fair is fair. They talk about the geometry, and there is science behind that geometry being good for noise, but for a C power cord, it just doesn't apply. And certainly as an interconnect, it didn't create an audible case. I then plugged it into my A90D and ran a frequency response test. Naturally, these two curves land right on top of each other. Absolutely no difference in the frequency response of the preamp. And that guarantees that tonality has not changed. So anybody wants to say, well, it's got more highs, more bass, less bass. It's just impossible. This graph mandates that they cannot have any tonality difference on this thing. And I mentioned that, you get a 121 dB SINAT when you use it as an interconnect. And I don't show you the generic one, but it's identical to this. There's just no difference. And notice that there is no noise spectrum over here to speak of, even though I'm using the cable, again, as an interconnect, and I'm in a very noisy environment. I have a full-blown analyzer running. I've got my desktop workstations running, got monitor. I've got tons of gear running in here. So it's much dirtier than your audio system is sitting by itself. None of that got picked up in here. What you see in here is basically performance of the analyzer itself on this thing with combined noise and distortion that's below threshold of hearing. So even as an interconnect cable, there's just nothing there. It's just, typical environment. So remember, I said to induce noise, I had to stick a transformer on top of the cable and rotate it to get the best case interference. If you don't do that, just have any distance, this is what you get on the measurements on this thing. That's at one frequency, but let's go at all frequencies, and we can see the distortion plus noise of topping A90 digital or discrete, and no matter what frequency we test it at, the noise and distortion does not change, and we're going all the way up to 90 kilohertz. So any claim that this cable provides noise reduction, it may on the AC cable side of it, but once you go inside the equipment has so much better filtering that it doesn't matter what you stick in front of the device. People say, well, this stuff's not music. Well, all right, well, we have 32 tones simulating music, and I measure the distortion with A90D with a generic chord versus this other chord. It'll make no difference. So, you know, it's very, very clear that there is just no difference to be had. There's a reason those audio files were silent. It's because even the most trivial implementation of a power supply is immune to these noises. Nobody designing audio electronics says, I'm going to assume that the incoming AC is pure and clean, and if it's not, my performance is going to degrade. I'm going to somehow shrink the soundstage and all that stuff. You're not. But I want to emphasize in this review that bulk of this testing was done with listening, and you're welcome to do blind tests if you want. I've provided the files. The nulling is as clean as you can get an Alter B. No debate that there's zero difference coming out of this thing. Now, somebody may say, well, you know, maybe on this device is good, on others wouldn't be. Well, then you better listen to my recommendations. When I tell you this is a great preamp, then that's what you want to buy. But I'm confident that I could run this test on a bunch of other devices and have it make no difference. Now, if you have some kind of hum and buzz and you disconnect the regular cable and you plug in this monster thing in there and it changes that for some reason, and it can because the ground currents change, okay, but I've never seen anybody buy an aftermarket AC cable for that reason. They all think their system was great, then they plug in the aftermarket cable, then all of a sudden veil is removed and the detail got better, what have you. And there's just, we've proven here with our ears and only our ears that there's no difference in there because the null tests powerfully show that, you know, changing power cables makes no difference on this thing. So there are many strikes against this cable in the specific, in that it's just poorly built, poorly assembled from point of view of that shrink wrap that moves. You can't plug it in, you can't use it. I don't even know if it's damaged my outlet now and enlarged the safety pin, so when I now plug in a regular cable, whether that's too loose, won't make a good connection, cause it to generate heat or cause it to not trip the breaker. You know, why would you jump through so many hoops and to plug in this monster cable, which, by the way, I didn't even talk about the cantilever force this thing puts on your connectors. No question in my mind, over time, you could damage and break lots of outlets. You could damage your outlet by the wall or power strips. You could damage this. I had to keep worrying that the whole thing wouldn't topple over. It's just going through so much pain for supposed benefit, but those benefits are simply not there. We know as a matter of engineering, it's not there. Matter of listen tests, not there. Matter of measurements. Okay, so we have proven that science works, that NASA is right. When you apply science, you can find that the Earth is round. And we've applied science in here. I didn't just deliver a monologue and say, whoa, you know, I've weaved these wires this way. Trust me, it's better than $2,000 cable, and certainly better than anything cable you get, and you don't have the correct system if you don't have these cables. Or that, you know, there's just layman's excuse that, oh, you get to a level where your system is so good that only then you hear the benefit of this. Well, okay, go ahead and show me this. You can pass an A/B test of the files that are provided blind, and then we can talk. Set up a camera, run the test 10 times. If you get 8 or 9 times correct, identify one versus the other. And I'll try to replicate that, and we can go from there. But I'd say this is the most powerful proof we have that in general, AC cables don't make a difference at all. And in the specific, we just have so many negative things in here that I absolutely cannot recommend this cable from GR Research. Okay? Hopefully you learned something. And by the way, this is a new technique that I'm going to use in future videos with nulling of 2 samples. See you in the future. Bye-bye. Future video. Bye-bye.